Hi everyone. Today I'm going to walk you through how to approach a system design interview using a real life example which was asked to me in my JP Morgan Chase interview, which is like designing a music streaming platform like Spotify. So I'll show you how to clarify your requirements, estimate a scale, and build a high level architecture and tackle key components of a Spotify, which is like streaming, search, recommendation. So what I follow is like when you start a system design interview, first we need first and most important thing is to clarify the requirements. So let's start with that. So we'll be thinking about Spotify today. So one thing is the functional requirements that we need to understand now first, which is the first and foremost thing, what I feel. And then, so before that, do not jump straight into diagrams. Ask questions to the interviewer, understand the scope, what he wants, and also separate the functional and non-functional needs according to what the interviewer wants. Or you can first tell him, convey your thoughts, and then ask him if everything is necessary, or you can skip few of them. So for Spotify, what I can think of is functional requirements can be first is the search. User should be able to search the songs and artists or playlists or albums sort of thing. Then he can have a music streaming. So for music streaming, it can be like a user can come in a real time. User wants to listen to a song, he can stream songs. So that is very important requirement. Then he should be able to make his own playlists. So user can create or share and modify his playlists. That is very important thing. Fourth and very important thing is music recommendations. So music recommendations are like based on their listening history. So users should be able to receive song recommendations based on what preferences they have set before, and also on basis of their music history. Fifth thing can be sort of an ad support thing. So this is very optional sort of thing, I'll say. This might be asked by the interviewer or he can skip it as well. So it is like you will have to, so for the free tier users, so if it is a business model, then he'll have a free tier users that will encounter ads after few songs. And if he has a subscription, then he doesn't need to listen to those ads. So this is very optional thing that he can ask you, the interviewer. So next, jumping into the non-functional requirements. Non-functional requirements. So non-functional requirements are generally, if you can think of, is scalability. So scalability is like the system should be able to handle 100 million users or 500 million users or some huge number of users globally, and it should be able to stream multiple songs concurrently. So this means by scalability. Then we should have low latency. So low latency in simple words means zero lag. So in real time streaming, we should have low latency support for users to have a seamless user experience. There shouldn't be any lag in between. Next is high availability. These are So high availability means the system should be available all the times, and there should be, if even if it is not available, the downtime should be very minimal. So that's very important thing. And the last I can think of is a global reach. Global reach means it should support users from different geographic regions, like let's say example India, or it can be United States. So for that we can leverage CDNs to serve audio files faster. So I'll come back to that later. CDN is like a content delivery network. Okay. So once you have done the functional and non-functional requirements, then you can assume. So let's do some rough capacity estimation. So let's say the users. So the user base can have total active, let's say around 500 million, and then daily active should be there. So all users might not be active daily, so let's consider it as 100 million. And let's say average streams, so one user can play 10 songs a day, per day, streams per day, it can be 10. Let's for now let's assume this. And also let's say the average size of each song is 5 MB, which you might know. and average duration of each song can be somewhat around 4 minutes, which is typically what we think of. Now, if we take these into account, so let's say how many daily song streams we'll have stream. So in daily, if I have 100 million users and also we have 10 streams per day, so we will have 1 billion streams per day. And let's think of the uh, let's say the total storage as well. Total storage. So let's say we have 100 million songs and we have also 5 MB per song. So it comes around 500 TB if you calculate it. So this is one more thing. And other than that, okay, let's say each song has 2 MB metadata. And if I have also we have 100 million songs. So it comes around 200 GB. So we need a huge DB space as well. So these are some on high level how much we need for storing basically. Okay. So after you have done all these things, like we have estimated the scale and all those stuff, so we can go now back into the high level architecture of what we think we can make for a streaming platform like Spotify. So let's think in a high level about the components what we can have. So as you know that the Spotify is a client application which can consist of a mobile or a desktop or a web version. Like it can have different, so you users can use a mobile as well or a laptop or a desktop. Okay, so let's say let's first draw a few diagrams. I'll choose a different color for that. Let's say this is a phone and we also have a monitor. So from here the requests will come into a load balancer, which we say. So you can think of a load balancer which will distribute the traffic. This is a load balancer, or you can see it as a API gateway. So the work of the load balancer is like to distribute the incoming request evenly across multiple instances of the backend services that we have. So it will evenly distribute it. So as I said that we'll have a app server, so we'll have multiple servers. So let's draw some servers. So these are the app servers and it will be distributed by the load balancer. Okay. Now, from the app server, let's think of what all services we can think. So one is very important is the streaming service. One we can think of is the recommendation service, which is very important. And also the user should be able to search. So we'll have a search service, right? Yeah. So these are in first thing we can have. Also, very importantly, we can have a sort of a user service. And this is very uh, optional thing that I'm saying. So an ad service, which I had told you, which is a very optional sort of thing. For the user, let's start with the user. The user can have a user DB. So let's draw a user DB. This is a user DB. And we can also, a user can also have a playlist. So we can think of a playlist DB. So these will speak to each other. And for the ad we can have some sort of a storage like ad file blob, which will play all the ads that we will have for the ad service. Okay. Other than that, okay, now what we can think of is like, so for So this is some rough idea that I can have. So now the streaming service, coming back to the streaming service, which will handle the music delivery. So instead of serving, so let's say instead of serving the audio directly from the backend server, which might be slow and expensive as well, we can use some sort of a CDN. So the work of CDN, which is content delivery network, is CDNs will store the audio files close to users globally so that playback is fast and will have low latency. So by that what I mean is we will have some sort of a CDN here, which is the content delivery network, and this will directly speak to the clients, and we'll also have a audio file store, that is a blob storage audio, and the streaming service also will speak to this one. And so instead of directly making it up from the app server, we can use it from the blob storage or CDN. So that makes very good sense for low latency. So for search service, and also one more thing, uh, in streaming service also we can have some sort of, let's say I'll erase this part, and what I'll do is from streaming service we can also have some sort of popular songs, which I just now remember. So popular songs, we can have some sort of a cache. So this cache will speak to here in the streaming service. So these songs will be directly played to the user from that cache itself. You don't need to go to the server and check. Now for the recommendation service, also we can think of some sort of a recommendation cache. Okay. Now coming back to the recommendation service. Let's think of what the recommendation service will do. So basically, the recommendation service will give us personalized suggestions based on what we listen, the listening behavior or the preferences that he has given. So it will Spotify's. It will what it will do is it will collaborate and use some context-based filtering, and it will give us real-time recommendations based on his previous hearing history and his preferences that he has given. Okay. Now let's talk about the search service. The search service is a very important service where it will typically we can use some sort of an elastic search to support fast lookup. And what I can think of for the search service is like so as I told you here it will have a search DB. So the search DB will use elastic search, which is very fast. Okay. Now, what all these will also speak to something called song DB, song metadata DB, or else where we will be getting the songs from. Very important thing. This is like some sort of a songs DB. I think I have covered most of the things. Let's see if we have missed something. We have these. These are so. This is the users or the clients, whatever you can call it. Yes. So for the databases, what I think is like the databases will store the user profiles, playlist songs. We'll also have a blob storage, which will like something sort of an AWS S3 for storing all the audios and add files because they'll be huge in number. And also we will need to use a content delivery network, as I told, which will deliver large files efficiently to users across the globe with minimal latency. And also we need all these caches here that I've told you. So these are like frequently accessed data, such as like popular songs and recommendations. These will reduce the load basically and also improve the performance. Okay. Okay. Now let's talk about the. Okay. Now let's talk about the streaming flow. How it will do. When a user taps the play button, the client will send a request to the API gateway here. So the API gateway will route to the streaming service, and now, and it will generate a streaming URL. When the client and then a client can receive a CDN URL as well, and then it will play the song directly from the nearest CDN if it is available. Now, let's think of some bottlenecks. What can come? So, if we think of some bottlenecks, what comes to my mind is like sort of scalability is one issue where, so these are the key issues that will might come. So for that we can use the sharding, like we can scale up the SQL databases and distribute them. And okay, so before that, let's okay, before going to the bottlenecks and all those stuff, let's talk about the DBs. What we can have, we can have some sort of a, let's say, so we can have a combination of relational and NoSQL DB. So we can have a, so let's talk about the DBs, quite databases that might be used. So we can have a users DB, which will have user ID. Then we can have name, and then what else we can have, email and all those stuff, his personal information, country, which is very important for CDN. Then we can have a song DB. Song DB will contain song ID. Then what else, title it can have, artist name, what else, duration, maybe genre also, based on the recommendation. Then we can have some sort of a playlist DB. So playlist DB can contain some things like playlist ID and to which user it belongs, so user ID as well, the name and the song IDs, the list of song IDs. Okay, sorry about that. Next, we can also have some sort of an artist DB, which will store all the information about the artist. So we can have the ID for him. We can have name and some bio sort of thing. This is like very simple thing that I think thought of. Now for the NoSQL DBs, which is for the unstructured data, we can also use NoSQL databases like Mongo, DynamoDB, or Cassandra. So that will be basically for searching, which I've told you. For the search DB, we'll use Elasticsearch. So it can have some sort of a record like song ID, which is in a JSON format, and then he can have title, artist, like that, genre, and all those stuff. And for the distributed storage, as I told, we'll be using S3 blob storage, which is a very ideal storage solution because it is highly durable and available. Yeah. Now, so going back to the bottlenecks and addressing key issues, we can have we should be having scalability. So to maintain scalability, we can use sharding, like to scale up the data SQL databases and distribute the load evenly. We can we can use sharding for larger tables like user, playlist, and song metadata type. We can also use indexes. So indexes, adding indexes on frequently accessed fields is very good, which will improve the query performances. And also we can partition the NoSQL databases because there will be huge lot of data. So we can distribute the data across multiple nodes. So for reliability, like to ensure very highly available Spotify, we can think of replicating the databases. We can use cache replication and auto scaling. Auto scaling is very important because it will improve that. So let's say someone suddenly uploads a song, some artist, very popular artist like Arijit Singh or Ed Sheeran, he uploads a song and there is a huge traffic to stream that song. So we need to scale up our servers based on the traffic load. So that is called auto scaling. And then we should have a graceful failover. If like one of the server fails, the traffic should be rerouted to another server without any service interruption. Yeah, to wrap up and summarize, always try to clarify the requirements and then try to make a rough estimate of the scale, and then we'll try to draw an high level architecture, and then let's deep dive into the core components like the streaming service, recommendation service, search service, and speak about them. Always talk about the bottlenecks and the trade-offs. And yeah, with this approach, I think we are not just drawing it, we are just also showcasing our thought process to the interviewer, which will be very helpful. Yeah, if this video has helped you, please like, share, and subscribe to my channel, and also comment which system design you want next. Yeah, thank you.